Okay, so hello everyone, and thanks for coming to this late talk on the second day of the conference. I hope you like the conference. And I specifically took this yellow color to be able to rest your eyes, so that if you want to sleep, that's okay. If you want to evocate, just look those doors and it's also fine. But for those who are not too tired, let's talk about mocks. And on the schedule, you see a slightly different talk title. It includes libraries. And many people approached me and they asked, are you going to give a tutorial on Mockito, JMock, and our libraries? And the idea that I'm not going to speak how to, what is Mockito and JMock API. Idea is that I will look to mocks from more general meaning and basically from design point of view, and what are the traps if you're using some popular libraries, in particular Mockito and JMock. And the whole essence is that I'm going to speak only about mock, not our testable types like spice or stubs. I will mention them, but the whole point is mock. And what you can bring home out of this talk is to understand what is the difference between those. I will also show some libraries, but my goal is not to blame them. The idea is that I want you to learn some hard things that I did over maybe 10 years and wasted so much time, so I'm going to show you something that you probably need to know while choosing a mocking library or while you are writing your test code. And all of the libraries that I'm going to mention, they are great libraries if used properly. Also, what I want to say that if you're doing something and you're happy with that, continue doing that. This is my story. And the only thing that I want to shame a little bit is religious use of libraries. For example, if you are a Java developer, how many frameworks you know that you can use to build a web application? For example, can you build web application without using servlets? How many of you can do that? Okay, there at least one, yay. So if you're, for example, Ruby developer, many people think that they have to use Rails. If you, once I had a chat with a person who, I asked him like, okay, so can you write me a web application? And he said, yeah, I can write it, but I cannot find Spring in your project. And where have you hidden it? And it was very surprising to me because the person expected that Spring is a part of JDK, and it was very surprising. And I will look into this pane of mocks by showing the panes, how I also wanted to learn about them by writing my own mocking library. And that mocking library is not for use, it's more about learning what mock libraries authors experience. So, motivation, frustration. Who here loves testing? No, really? This talk is because I hate testing, and that's because I hate it. I don't want to repeat something twice. That's why I automate it. And this is how I discovered mocks. So I have so much frustration. I don't like mocks at all, but I have to use them in some cases. And this talk is not about promotion of mocks. There are different design alternatives that you can use to implement your architectures. And another question is, that I hear okay, but I was in some talk and the dude there said that mocking sucks, mocking breaks your design, mocking is a smell, and so on. So I also want to slightly go away from this. I think it depends how you use it. Also, I wasted so much time in debuggers just because I misused mocks. And the whole point is that mock is there to help you, not to make your life miserable. And also religious obsession of some tools. For example, how many of you use Mockito? Okay, everyone. I also use Mockito a lot, but how many of you know JMock? I'm asking no. Okay, at least a couple of you. Okay, great. So after this talk, at least you will know that there exists another tool that you can use instead of Mockito, and it's worthwhile looking at it. Okay. First part will be about more about theory and why do we care about mocks and where those mocks come into the play. Then we will look into actual frameworks. I will show you some code how Mockito is usually used. It doesn't mean that it has to be used that way, but usually people use that because this is the first example on their page. Also the same about JMock, and those principles apply to our JVM libraries. And the third part is like, I said, okay, I can do it better. And I did an exercise and tried it, and I have mixed results, but I want to share with you about what is experience to write your own mocking library. So, a little bit about me. I'm from Vilnius, Lithuania. I organize Java user group events there. If you happen to come to Vilnius or you want to give a talk, just come and talk with me. I'm a software developer, like 15 years plus something. Probably doesn't matter. Recently, I started to code in Scala, and it's already third year that I'm doing that. My company is very proud TDD culture, something, and like we promote TDD, and that's why I worked for Wix. And TDD is not about test. It's not only about testing. It's also about designing, and this talk is also about part of this. My main interest is in software design. If you want, you can follow me on Twitter and maybe go to my website where you occasionally can find something that I write. It's not very frequently updated, but you can just go and take a look. So let's start about testable design. So what is testable? Testable is something that you can break apart and make sure that all those parts work separately. Why is that important? Imagine that you're building some aircraft. You don't want to try it in space. You want to know that individual parts work already on Earth. So you need to break things apart. And design here comes as a thing that allows you to improve those parts in the future. So those are two things that we care about designs. And so what is design as a whole? So how many of you have read this book? Cool. Okay, so how many of you know Sandy Metz? Maybe you watched the video by her. I recommend this resource, like this book. It's an amazing book, and it's very good for Java developers because we live in some world which is constrained by types. And this book is also about object design. It uses Ruby as a language, but it doesn't matter because it's more about design, and they solve some problems that we live in some comfort zone, and we don't know that such problems exist. And to me, after reading this book, I think I started to think slightly different about my designs, and it's a very recommended resource. And what it says that object-oriented design is about managing dependencies. It's not about internal structure, it's about how you depend with something in your system. And bad design is something that, for example, if you have to change one part of the system and that explodes into changing all the dependency tree. This is a bad design. So this is the essence. Another quote says that good design allows you to change or do design later in the future. So the purpose that we do design is not about just having beautiful code. Beautiful code is a personal thing. No one pays actually, like customer doesn't pay for beautiful code. Customer pays for something that is easy and cheap to change in the future, and that's why we do design. This is another book that I think for Java developers it's a must-read book. It's growing object-oriented software guided by tests, which is not so much about tests, but more about designing systems and growing them, changing them. It's by Steve Freeman and Nat Price. They're known as promoters of London School test-driven development. And what they say that design is gaps between the objects and communication protocols. So idea is that, again, we don't look inside the object. Inside the object, we can do whatever we want. What we actually care how those objects compose together. So this is, again, what design is about. So integration is the hardest part. Again, what they also say that as the Java developers, we use interfaces everywhere. And what they say that interface describes where two components will fit together. So interface is like static thing. It's like two Lego parts. You try to put them, and they only fit if they are made to fit. So it's not that important. What is really important if those things can work together. So what they mean here is behavior. And this is what is important in design. Again, nothing about strictness, nothing about internal parts of the design. If we do Java, we get a lot of those strict and internal things defined by the language. So we're kind of happy with that. Okay, so what exactly is testable design? So imagine this is our typical application. So we did it. We have UI, we have some logic, sometimes we don't. It's a CRUD application if we don't. And we store data into database and maybe retrieve and read from that and then display it in UI. So this is our typical application. Sometimes we have more UI, sometimes we have more storages or maybe some messaging system, email integration and so on. So idea is that what we are trying to do, we try to push the code that is application specific into this middle circle and surround it with the boundaries so that we don't have to deal with UI and we don't have to deal with database. And the only way to communicate with those external systems, like those systems that actually we are doing side effects to. For example, side effect is to write some data to database or read from it. Also, side effect is to display something maybe on the screen or maybe in browser and so on. So we want to isolate from those, and we put a boundary around our application logic. And that application logic is where we can do whatever we want. And this is our goal. And this is where we can mock things, we can fake them, and this is the essence what I'm going to talk about today. Also, you communicate with external systems through ports, and you control those ports. You write adapters which belong to you, and you define interfaces of those ports. So everything here in the middle belongs to you. That's the idea. If UI or database change, you just change UI or the storage adapter which belongs to you. And that's the point of it. And this architecture is also known as ports and adapters. And the idea is that you can replace external systems with equivalent ones and even sometimes fake it. For example, if you have a system which has UI, maybe you want to change that UI with some automation tests. So that type of architecture allows that. Also, this architecture is known as a hexagonal one, and I quickly explain why it is hexagonal. Imagine that we have our great application which does a lot of business logic, and then we know that that logic produces some data or works with data that is stored in MySQL. But the whole idea is that we don't need to know that our storage is MySQL because we communicate through ports. And also, you see, this is hexagonal architecture just because it's convenient to display on the screen. And we can just place together those hexagons, and visually they look like nice. And MySQL, on the other hand, it doesn't know about our application. It doesn't care, like, if application has some logic inside, it provides its own interface. On the other hand, application doesn't know about internals of MySQL, for example, transaction log or something like that. And we can go further and talk the same about JavaScript UI. We can even develop JavaScript UI as maybe single application, single page application separately, which has its own tests. It can run some integration on their level. It abstracts browser and abstracts some display logic from us. The same can be said about acceptance test suite, which also is some implementation detail that is decoupled from application. Then we can talk about production end-to-end tests, which run in our production system. For example, it doesn't care if this one is real or fake or something, so we can bring this one to production and create it to work in production. And about backup service. Why do backup service needs to know about maybe our JavaScript UI or application? It just needs how to communicate to MySQL and dump data and store it for later recovery. So that's the beauty of decomposing the testable architecture. And now the main part, let's talk about mocking. I'm going to show you a couple of examples of how we typically use Mockito and JMock. And when I say we, I don't mean the company that I work. Well, some examples probably are exactly copy-paste from my company, because we use both frameworks. But the idea is that we as developers, and let's start with Mockito example. So here, you don't need to know much of Mockito. I will quickly come up with the DSL that it uses. I specifically omitted one line just so it illustrates the problem that we'll have in a moment. And let's see if this works. Oh, you cannot see it on the screen. So this is a system that I'm testing, and that system depends on finance. So if I want to generate a report, I need to call finance for some reason. It doesn't matter why, I just want to show this dependency to you. So question is, what will be the output of this test? Well, I think this picture explains it, and we usually get a null pointer exception. And this is where the problem is, that null pointer is already a consequence of our action. It's not a feedback, it's already a broken system. So this is where Mockito doesn't help us. So to fix that, we need to tell our mock to return something on, and you can see that it's not really visible what exactly happened. It says that, okay, it tried to do something with report total, blah, 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 but it didn't say what happened. So here, to overcome this and to make this test pass, we need to use Mockito DSL, which is very nice. I think this is the strong part of Mockito, that it provides very beautiful DSL. I think this is the reason why so many hands were up, because it's so easy, readable, and by the way, it's also the essence of mocking frameworks, because mocks, like, you can create mocks without using any framework. What framework allows you to do, it allows you to inline some DSL to describe behavior of dependencies. And this is, I think, the nice idea which makes your tests more readable. Okay, and also, sometimes if, this, by the way, was a stub. Stub is something that returns value. Sometimes we also want to make sure that this stub or our call was called, and this is called spy. So you just learned about two our testable types, which are stub and spy. And what is inconvenient here, that I can make mistake in verifying, and also can make mistake in this statement, for example, I can add something that is not even get called. And you may think that it works, but it doesn't. Okay, so Mockito just turned my test into something that I have to debug. And this is the problem with Mockito. It works like a patch. I just run something. If I make mistake, then I go and I try to patch hole, and I try to guess. I don't get a normal feedback from the test what exactly is missing. I just have to guess, maybe analyze stack trace. It's good if stack trace is complete and it's close to the problem, but sometimes we're not so good test writers, and maybe we do some indirect calls and something, and then it becomes really hard to debug it. Okay, so let's look at JMock. And now it will be really, now it will explain why people don't use it. So this is JMock 2 example. JMock 1 was used a lot of reflection, and I think people didn't like it much. So with JMock, again, we are using like the same system. We have to create mockery, which is a bit more explicit API. Then we create a mock, and in the end, we also need to ensure that our mocks were called. And guess what is the output of this one? And output is illegal argument exception, because Mockito doesn't allow you to mock interfaces, which is a difference from, I'm sorry, JMock doesn't allow you to mock interfaces, and which is a difference from Mockito, and where in Mockito default behavior is to allow you create mocks of interfaces, which is I think is good idea, because it's an obvious problem in the first place that we usually have one interface and one implementation. And we have really good tools like IntelliJ or Eclipse, which allow you to easily refactor them. Also, one thing is that if I'm a user of that interface, do I really care to know, is it an interface or is it an implementation? Like, I still get a listing of public stuff that is available through my class. But it doesn't solve some things like inversion of control. For example, if you don't want to couple to implementation and want to have some indirection, then you have to extract interface. But I think, again, like if you don't need it, it's probably useless thing to do. It's over engineering. If you need it, I think you can do it by just extracting. And when do you need inversion of control? For example, if you give your API to a customer, or you have some remote call thing like RPC or something else. By the way, if you have questions, just feel free to ask. And another thing is works versus fits together. So interfaces are in fits part, which is like not so much important from design point of view. On the other hand, Growing Object-Oriented Software Guided with Tests, that book promotes extracting interfaces in the beginning. Okay, so, but there is of course a hack, and you have to use an ugly line to tell JMock to allow mocking of interfaces. It basically will use different technique to create proxy of the class that it creates. Okay, so what is the output now? So the output now is different from Mockito because it tells you what exactly happened. So it says that it was expected. Didn't expect anything, but something happened. And this is a good output because you now know what's going on. For example, maybe you made a mistake in specifying mock or did something. You don't have to go and debug your null pointer exceptions. What you need to do is just look at this report and basically make adjustments. So this is a nice part, which also exists in Mockito, but nobody, well, almost no one knows how to use it, and it's very deeply hidden in documentation. So now the ugly part of JMock, and I think this is the part why no one is using JMock, is that stubbing, previously in Mockito, it was just a simple expression. Here you have to provide two expressions, and I think this creates temporal coupling, where if mistake happens, it's very hard to find out what's going on. So it has some implicit behavior which you need to know from documentation or somewhere else, and also it has additional boilerplate code around your stubs. All right. So what's wrong with Mockito? So first of all, if you have noticed, I didn't do much. Like this assert is satisfied is actually optional thing. Like all the expectation testing was specified here. So if, for example, report generate for will not call this one, will call this one with, for example, different parameters, this one will break and this line will not be reached. So what happens is that we break given when then style, so it means that our then part gets encoded before we actually execute the system, which is very confusing to some people. But I think you can get used to that. Also, risk of overspecification, because if you are expecting your system to use dependency in some way, there is a risk that you will have to list internals of that system, of how you use the system. So your implementation details may leak into your test. And again, looks like an old product because Mockito DSL is so nice. On the other hand, pick one, verbose and implicit, and I think both of those libraries they do a lot of implicit stuff. For example, Mockito and JMock, they use some context which is not so, like in JMock, if you use it with, like I did without JUnit integration, it looks like, it looks very explicit, but it looks very verbose. So it's a choice. Like, but with JMock, you can bring in JUnit integration, and JUnit integration hides a lot of mockery creation details. But this may create another set of problems. Okay, so to recap Mockito and JMock, essence is point number 3, which I don't want to debug. And the essence of writing tests is to get feedback as quickly as possible. I don't like testing. I don't like debugging. And the idea of testing is that skill of debugging should go away. Like, if I'm good with debugging, this is, maybe it makes me proud, but but it's a feedback about what you do, that you're doing something very complex, and this is not something that your customer or your manager wants to pay. Your manager wants to get to the finish as quickly as possible, and debugging doesn't help you there. Reporting, as you've seen with JMock, this is what helps achieve quick feedback. You don't have to learn debugging tools, you just read expectation report. So, what you've seen in Mockito was spy, and what you've seen in JMock was mock. And even though that Mockito is called Mockito, which starts with mock, usually people use it as a spying framework. And spying is postmortem look into system under test after it was already exercised. So it's like you execute system, it may crash or no, and then you assert if it worked correctly. Expectations stop execution immediately after the first one fails. So this is the essence, and then you can understand what's going on. And J.B. Rainsberger said that a spy and the stub do the same thing, and they only differ in intent, and in what follows you can treat spy and stub as synonyms with, I think, no risk of confusion. And I think what he wanted to say is that there is a big difference between expectations and spies and stubs. So expectations are doing one thing and spies and stubs are doing different things. And I think expectation is what we should aim for. So what community thinks about it? So community thinks that in this book, like, first of all, mocking is very good for tell-don't task. And tell-don't task is a principle which prefers sending commands versus querying objects. So it's object-oriented principle which says that a good object-oriented system should send messages to objects and tell what to do versus ask data from them. So this is where you usually don't get a return type. That's why you need mocking. Also, another thing that you need to know is that you mock only types that you own. And types that you own are those that you can make sure that they work as you expect them. So for example, you shouldn't mock third-party APIs, but you should be able easily to mock the things, interfaces or classes that you've written yourself. And the point is that you should mock only things that you trust. And another maybe smell is that don't mock values. If you mock values, it means that your values are hard to create. Maybe they're too complex. So this is a smell, and if you feel it's easier to mock a value instead of just use constructor, then it means that maybe it's too complex. Another maybe opposing view is that some testing frameworks, for example, Spock also brings their own mocking frameworks, and they are enabling lenient behavior, which is allowing like unexpected behavior by default, like Mockito, and they believe that this prevents from coupling with your implementations. So this is like an alternative view, and I think many people in Spring community believe about it. Okay, so this is the third part. Third part is about how I spent my last Christmas. So this is the best time to talk about it in sunny weather. So I did the most stupid thing. I decided to write a mocking framework myself, but I will have some excuses why I did it. So first of all, I do not intend I didn't expect that someone is going to use it, so it's not even like published to some Maven center or something. It's also a good exercise for kata, so it's like an exercise that you can do to learn and improve yourself. And I also wanted to understand why the heck mocking framework people create so hard to use APIs or something that is hard to, doesn't drive your test feedback. And also I wanted to understand, is it possible to improve the syntax by just using Java 8 mocking Java 8 features like lambdas? And another essential thing that you need to know if you are creating your mocking framework is how to create proxies in Java, and I wanted to learn a specific tool which is ByteBuddy. So everyone can be taught to sculpt. Michelangelo would have had to be taught not to. So it is with a great programmer. So sometimes we are so used to some principles that we need to go back to the beginning and try to experience something as we were just fresh born. So first of the challenges is that I wanted APIs to be explicit without any surprises. And this is comparison of what I've got. So on top you see Mockito, which is really nice DSL. I think Mockito just nailed DSL very well. It has some problems because what exactly happens here? Because you know that Java by default is called by Valuia, and so it means that this collaborator actually is going to be executed. Then JMock is very verbose. It's very explicit, a bit confusing because you need two expressions, but it's more self-contained because everything happens under mockery. And this is what I came up, and basically I stole many things from Mockito and also wanted to solve that side effect that happens here. with using Lambda, so it's like a trade-off. It doesn't look very nice compared to Mockito, but at least you can isolate, bring in execution inside the mockery. So this is not going to be executed because it's called by name. Okay, so explicit side effect expectation. So what I wanted to do, I wanted to get separate APIs for side effect. Side effect is something that doesn't return value. So you just send a command. So it's like calling a void method. So this is how it looks. And you don't have to call mockery verify because like this one is only needed if nothing happens and you want to make sure that those expectations are actually reported as unexecuted. Similar thing with stubs. I say query, and then it allows me to return something. Another challenge, implement mock creation. So here I'm using bytebuddy, and this is my API still. You cannot see bytebuddy. My question is, how many proxies do I need to set up and then use mock? So for mock, first of all, I create a mock, and it creates a proxy. Proxy is like fake implementation of my class, which delegates execution to some internal thing that doesn't matter what it is. And another thing is that when I execute this Lambda, I also call it, but it's not mock execution, it's mock setup. So for this one, I also need another proxy. So here, like you can do it with one proxy, but it means that you need to maintain state between those. So I decided to use two proxies. And for this, I'm using bytebuddy. It's easy to use library. Docs are good, but they're not perfect. Still, I had to spend some time to find out how to do very simple things. But on the other hand, like Googling, Stack Overflowing, and it helps a lot to find answers to your questions. And Author is very, very responsive. So if you want to use library which generates bytecode, I think this is the best on market now. It's also very fast. The runtime generation is very fast compared to some other libraries. Okay, so what it does, so you just take bytebuddy and you say which class to mock. So basically pass a type and then tell what to do when it can intercept methods, and you say, okay, let's delegate it to something. And that something is my own thing, which is, okay, it's not actually my own thing. It first delegates to this interceptor, and then I can delegate to my delegator, which is my own implementation, which does whatever I need to do to either set up a mock or use a mock. Okay, another challenge, reporting invalid stubbing. So, for example, in Lambda, you can write something which is not even related to a mock that I'm trying to stub or query. So, for example, I can call a field, and that field, neither in Mockito or JMock, it cannot be mocked. So, what the problem is that I want my user to know about it, and this is what I was aiming with my implementation. So the goal is to make reporting explicit first-class citizen in the framework. Also, like you can see, if I call Lambda, it's valid Lambda, it will be accepted by command, but you cannot mock anything by this call. So JInsist will tell you that, okay, method to stub was not found. So this is how it looks. And challenge number 4 is, again, as I meant, like I need explicit feedback. And it's important to know two things, like what has happened and what was expected. So it's like a history replay. It's like time, like log of the events that happened with your mock. mocks under test. So you can guess where I stole it. I just looked at JMock and got influenced a lot from them. All right. So where does it fit? So definitely it doesn't fit for legacy testing because it forces you to create expectations, and in legacy systems, if you don't have tests, and if you need to add a new test, you will need to specify a lot of details, and it may become very hard because not all of legacy systems are designed to be testable. So maybe you should go with Mockito, and maybe if you need power mock, for example, if you have static methods. It also fits very nicely into rigorous TDD development. So if you want a really quick feedback loop, you will get expectation quickly, you will fix, and it will allow you to move really fast. And I wanted to make clear statement on simplicity, and when I mean simplicity, that I don't have anything hidden implicitly, and it's very clear. Maybe syntax is a little bit verbose than what Mockito provides, but at least I know that mock stubbing doesn't escape the context. And another thing that really struck me is that Mockito is very, very huge code base. So it means that it does many things in very different ways. For example, JMock, which I think has some features that Mockito doesn't even have. It's like so much smaller code base. And JInsist, of course, it lacks a lot of features. It's just like 2,500 lines. And regarding Java 8 features, I think it allowed me to capture stub setup, and I think this is a nice thing. Maybe in future Java versions I would be able to write it more concisely. But other than that, this is the main important thing, is that I was able to do call by name thing. And lessons learned, just use existing tools, but understand how they work and do they really help you in daily work. And thank you. Anyone has questions? Okay.
Hi. Do you compare speed of testing, for example, same functionality by your framework and, for example, Mockito or JMock?
It actually very, like, if I use my own framework, and for example, if I use JMock without any JUnit integration, it's more verbose. You have to write more lines, but I think it's very easy to create a JMock integration, and then it will look maybe the same as, maybe even less than Mockito, because in Mockito, if I want to verify mock execution, then I have to have verify statement, and in the end, in JInsist, you just need single statement which sets expectation, and if that expectation is not met, then you
I mean, not writing of tests, but after you write tests, you run it one by one every build, yeah?
Mm-hmm.
And I mean, this part, when you execution process.
So
do you compare?
I haven't compared. Like, do you mean like how quick is the framework?
Yeah.
I haven't compared. I think it's like acceptably fast. I think like that mock creation like is very fast. I think Mockito does under the hood. Like, it has byte-body implementation. I don't think it's like cannot be much faster. It probably uses the same technique. And it has alternative implementation, maybe with JavaSist. I don't remember which one. But it should be very like it's milliseconds. Anyone?
Thanks for your speech. It was really interesting. I have a question about PowerMock. Do you consider PowerMock using PowerMock like an anti-pattern?
Yes, I think even like some people even say that using mocks is an anti-pattern, because if you need to use mocks, then it shows you that you depend on some external system, which the more you depend, the harder your life is. And PowerMock says that you have very complex things like singletons in your system, which complicate your life too. So I think if your system is hard to test, which means that you hardly can mock something, and you need to use PowerMock, it's like a smell of your design.
Thanks.
Anyone else?
Okay, thanks. You can
So
ask.
thanks for coming, and I know it's late, and thanks for staying, and thank you.